All right. On to the example. An elevator is initially at rest. The elevator is given an upward acceleration of 4 meters per second squared for 3 seconds, then continues without accelerating for 10 seconds, and then is given a downward acceleration of 6 meters per second squared for 2 seconds. What is the maximum speed reached by the elevator? How far is the elevator displaced after all of this time? All right, so first thing, let's identify what are these 3 segments of motion. The very first segment of motion, we are speeding up, upward acceleration. So we're going to say it's a positive acceleration here. Next, continues without accelerating, so it's constant velocity. Careful, Mr. Scopetis. Constant velocity, no acceleration for this third one, or for the second one. And then for the third one, we have a downward acceleration. So we have a negative acceleration. So things are just starting to get a little bit hairy. So we have a negative acceleration here. Meanwhile, we have a positive velocity. So we are slowing down here. And maybe you want to notate this a little bit better than positive acceleration, negative acceleration. Maybe you want to say speeding up, or slowing down. Either way works for me. Of course, if you are moving in the same direction as your velocity, or if your acceleration is moving in the same direction as your velocity, then you're speeding up. If your acceleration is in the opposite direction as your velocity, then you're slowing down. All right, let's get to it. The initial position, I think it makes sense to make it 0. The initial time, let's go ahead and drop in zeros all the way down the line there. Uh-oh.
Teachers and students.
Well, that was delightful. We know that the acceleration here is 4 meters per second squared, so we can throw that in there, for 3 seconds. So what is our displacement? Well, to find displacement, we're going to need velocity, aren't we? So let's find our ending velocity. So that'll be the first one we're looking at right here. So we have VF equals V naught plus AT. How do I know to use this equation? Well, I have acceleration and I have time, so I can find velocity. If I have velocity, then I can get my displacement. My initial velocity is 0, plus 3 times 4, my final velocity is 12. All right, so now what? What about we know this is 3 seconds. We know displacement is going to be velocity times time. The average velocity times time. The average velocity, initial plus final, is 12 divided by 2 is 6 multiplied by the time, which is 3 seconds, gives us a displacement of 18. So our ending position is going to be 18 because final minus initial. That just means we're 18 meters away from wherever we started. Next, we're dealing with constant velocity, so we already know that means no acceleration. Velocity is unchanged, and is that all we can pull? Oh no, it's without accelerating for 10 seconds. So this time interval is 10 seconds. So that means the ending time right here, ending of this segment, is going to be 13 seconds. So we're at the 13-second mark. And here we are again. We have velocities. We have starting velocity, ending velocity, and we need displacement. So we're going to come over here to this same equation. What is the average if we start out with 12 and we end with 12? 12. That's right. 12 times how long were we moving? 10 seconds. 10 seconds right here. And we get 120 is our displacement during this second interval. So now 120 plus this 18 will give us 138 here. Let's move on to slowing. We have a downward acceleration, so we have a negative 6 meters per second squared for 2 seconds. So if we are decelerating, that means we're going to come to rest again, right? Eventually, we will come to rest, so we'll set our final velocity to be equal to 0 here. We know it started out at t equals 13, plus 2 more seconds, t equals 15. Now we just need to find this last displacement, and then we can add that to our previous position to get our final position along the y-axis in this instance. So we're going to use this same equation. We have a starting velocity, we have an ending velocity. 12 plus 0 is going to be 12 divided by 2 is going to be 6 times 2 seconds is how long we're accelerating for. So that's going to be 12 seconds. Whoa! Wrong spot, sorry. 12 meters is our displacement. 12 plus this gives us a nice number of 150. Now let's graph. For the first segment, it lasts for 3 seconds, so we go to 3 seconds. And our ending position, because when we look at a graph, first thing we looked at is position versus time. So we have position versus time, velocity versus time, and acceleration versus time, and we're going to fill those in. So our ending position is going to be 18, so we need to find roughly 18 at 2 seconds, or excuse me, at 3 seconds. So each one of these is going to be 10, 20, right here. Now we are speeding up. What does speeding up look like? It looks like on the graph, right? Those shapes that we talked about memorizing way back. That's great. That looks terrible. 3 here. This is quality and infotainment here. There we go. All right, next up we're moving with a constant velocity, so we are going to have a straight line, and we'll switch colors for the second segment here. And we're ending at 138 meters. So 50, 40, 30, and t equals 13. So we're ending right here. And we know this is a straight line because it has a constant velocity. So there we go. And then finally, we are slowing down. Slowing down means we're curving to that asymptote, right? To the 0. Our velocity is decreasing until it gets to 0. And our ending position is going to be at 150 at 15 seconds. So there you go. There you have it. Now all that's left to do is to translate this into our velocity versus time and then acceleration versus time. For the first one, our speed is constantly increasing until it gets to 12 meters per second. Then it stays constant until t equals 13 seconds. And finally, we come back to rest. We have a constant positive slope for the blue segment. And then we have a 0 slope for the next segment, the green segment. And we know that the slope of a velocity versus time graph is acceleration. Then we end with the yellow segment, constant negative acceleration.